problem. I have a hose, and if I have water flowing out of this hose, and I press my fingers here, what do you think is going to happen to the velocity of the water? Well, let's find out. It increases. Same thing here. If I have a sink flowing, and I close my fingers on this, you can see the water moving more violently and moving at a faster pace. So let's find out why this happens. Let's solve a similar problem to answer why when I press my finger over a sink, the velocity of the water coming out will be faster. So here we go. A fluid flows through a pipe with properties shown below. Here's our diagram. Find the velocity and pressure at point 2. Take density of water being 1,000 kilogram over meter cubes and gravity being 9.8. So here we go. At point 1, the tube has a radius of 1. Fluid is flowing at 2 meters per second. The height is 0 and there is 800,000 pascals of pressure. At point 2, there is a radius of 0.5. The height is 3 and the velocity and pressure is unknown. To find the second velocity of the water, we have to use the equation known as the continuity equation, which states that the area 1 times velocity 1 equals the area 2 times velocity 2. So let's just plug in our numbers. We know area is pi r squared, so the first one would be pi 1 squared times our velocity, which is 2. Our second area would be pi 0.5 squared times our velocity 2 value, which we don't know. So this number here is just going to be pi times 2, which is 6.28. And this number here is going to be 0.785, and our velocity 2 we don't know. So to find our velocity, we just have to divide 0.785 by both sides. And we're going to get a value for velocity at 8 meters per second. So how does this connect to what we did before? Well, as you can see here, the radius, or just the area, because they're proportional to each other, is more at point 1 and less at point 2. And it says here that when the area is less, being pi 0.5 squared, the velocity is more, being 8, which is more than 2, which was the velocity at point 2, which proves that when I put my hand on a sink or a hose, the area that the fluid is coming out at is less, which means in turn the velocity must be higher. To find the pressure at point 2, we have to use the Bernoulli equation, which states that pressure at point 1 plus 1/2 density times velocity squared at point 1 plus the density times gravity times height of point 1 equals the same thing but just for point 2. So let's start plugging in some values. So our pressure at point 1 would be 800,000 plus 1/2 our density at point 1, which remains constant at 1,000, and our velocity at point 1 is 2, square that. And since our height at point 1 is 0, this should cancel out and we won't have anything for this side. So pressure at point 2, we don't know that, that's what we're trying to find, plus 1/2 our density stays the same, times our velocity, which we got was 8 squared, plus, and this we do have a height, so we do have to calculate this. The density, 1,000, times the gravity, 9.8, times the height, which is 3. So since this side is all numbers, we can just work that out. And since this side is almost all numbers, we can just work that out, and that's going to get us a value of 61,400. And we still have our pressure 2 value here. So we are just going to simply minus 61,400 on both sides. And that's going to leave us with 740,600 as our pressure 2. And this is going to be in pascals. So let's test this out. So here we have our exact setup from the board here. Our velocity 1 is 2 meters per second, our pressure 1 is 800,000 pascals, our height 1 is 0, and our radius 1 is 1 meter. And our radius 2 is 0.5 meters, and our height 2 is 3 meters. Let's get the predictions on screen and see what the final values are. So let's run this. And let's click show pressure and velocity values. Yes, as you can see here, our pressure 2 is 740,600 pascals, and our velocity 2 is 8 meters per second. And yeah, that's the video. Thank you for watching.